I'm Massimiliano Di Bitonto. I'm a student of Fab Academy here at Frosinone at Officina Giardino. And today I will want to talk about Internet of Things and natural interaction to share my vision and my researches, my experience about this topic. I'm a PhD in computer science, and I'm also a researcher at Link Campus University, that is a university here in Rome, and my research topic is natural interaction, and especially the new paradigms that we can use to interact with computers, so the new ways that we can use to access technology and information and digital services. Here there are some references, some readings that are related to the topics that I will see today, and so I will share the presentation so we can look at it. And so let's see the scenario that we will refer to today. I want to try with this lecture to give you a framework just to understand what is the Internet of Things and what are the design strategies that you can use to imagine how to interact with technology, and so also to understand why do we need technology or why do we need to interact in a certain way. So let's say we are already used to have a lot of digital devices around us, devices that are able to sense data, share data over the internet, and so for us, it could be normal to have a device that tells us if we have to water the garden, or if our dog is going too far away, or let's say if we go to run, how many calories we burnt during our exercise, taking a log of our exercises, and so on. So these are also all stuff that 20, 30 years ago would be some kind of magic, and now for us it's quite normal. But when we have a lot of device around us, it means that digital technology and computation that is meant as the ability to process information is present in a lot of aspects of our everyday life. It means that the physical and digital world are melted together. So now we start thinking that every single object could send something, or could think about something, or connect to other objects. So it's like that every single object could be smart, or could have like a shadow of information. And for this reason, technology is becoming a very big part of our everyday life experience. So we cannot stop to thinking only to the functionality, so how technology help us to reach some goal. But we have to think how is the experience of interacting with technology, because it can change the quality of our everyday life. So from a cognitive and ergonomic point of view, it's clear that the way we interact today with computers could not be the way we will interact with the Internet of Things, with the connected object, for example, with the smart appliance in our domotic environment or inside a smart city. But we can think about for example, the Nike Plus that is used when you go to run, or other devices that you use when you are doing something else. So you cannot use a keyboard, a screen, a mouse, or something similar. But you have to use something that is closer to the way that your body and your mind works. So we have to look to different kind of paradigms and different kind of devices to do this. And we can see that already in the market we have devices like Google Glasses that with the paradigm of augmented reality give another way to access information. So we don't have a screen, but our sight is the screen. We don't have a keyboard, but we can interact through our voices, just telling what we need to the system. and there is just a little touch that we can do on the glasses, but the interface, the physical interface, is very, very minimal. Or we can interact using gestures. So there are a couple of rings that you can use to move your hand in the air, and it became a command. The computation is embedded into objects, so we can have objects that are really that they don't have buttons or screen, but they can interact with you, or they can just act automatically. The automatic doors that are the entrance of every supermarket are smart devices that are able to feel the presence of someone, and opens without any command from the user. So they could be seen as one of the very first example of natural interfaces. So just have a quick look, looking about what is the relationship between man and technology from a cognitive point of view. Why human beings need technology? Since the beginning of our history, we created tools and artifacts to help us mainly in two ways. One way is amplifying our capabilities. So we use, for example, electric motors to be stronger when we want to lift something or we want to drill a hole in the wall. We use electric motors. We use a motor in our car just to go faster, or we can use technology to simplify tasks to be done. So we can use a tool to make something simple. But when we use an artifact, a tool, a technology, it has two main drawbacks. One is that we are changing not the goal, but the task we are doing to reach our goal. Imagine washing our clothes. When we use a washing machine, we have to learn how to use a washing machine. And the task is very different if compared with washing by hand, because we have to load the machine, put the soap inside, check if there is electricity, and then choose the right program. So we changed drastically the task, and we also had to learn new skill. Imagine the skill you have to learn when starting driving a car, or when starting to reading and writing. But if it's quite simple to think that help us from a physical point of view, when we are talking about something like reading and writing, we are telling about cognitive capabilities. So we can say augmenting to find technology that can augment our cognitive performance. Donald Norman says that cognitive artifacts are artificial devices that maintain, display, or operate upon information in order to serve a representational function and that affect human cognitive performance. What does it mean? It means that when we write down something, we don't have to keep it in memory. So the mental effort is less, even if we had to learn the ability to read and write. As a consequence, so the consequence of the technology changing the task to be done is that things can make us smart, or things can make us dumb. Of course, if a technology forces us to make more steps to reach our goal, or if the skill that we have to learn is too difficult to learn, so things are making us dumb. But if I learn some skill and then the technology really simplifies my life, then the thing is able to make me smarter than before. So the computer, of course, is a cognitive artifact. So an artifact that can help people to augment their cognitive performance. However, there is a big difference between a normal artifact and a cognitive artifact. Because we can see in the image, I put an air dryer and a computer. Of course, an air dryer is clear for me what is the primary function. For a computer, it's not the same, because the computer doesn't communicate with its form, its functionality. is the human-computer interface that will communicate what is the main function and what I can use it for. So it's in a task of a designer to decide how to communicate the functionality and how to set up the dialogue between man and computer. Even because a computer is almost everything today. A computer could be a washing machine, a car, a smartphone, everything that could be programmed to carry out a set of arithmetic or logical operation automatically. So it's for this reason that we are talking about Internet of Things. It is a scenario that is related with the presence of computers all around us. This can be seen as a consequence of Moore laws. Everybody knows the Moore laws that talk about the speed and the cost of microcontroller. Well, a consequence is that as microprocessor became faster, then the slowest microprocessor become cheaper. So in the last assignment at Fab Academy, we used a microcontroller. We used the IT Tiny, that is a very small microcontroller that can be used, I don't know, to turn on or off a LED, or it can be used to sense temperature or light or other variables. It is, of course, really cheap, so we can develop our smart object just with few dollars. We don't need a powerful multi-core processor. So it is an enabler of a new era of computing. If we had in the 60s the era of mainframe, so one computer for multiple users. Then in the 80s, we had the age of personal computers, so one computer for one user. Now we are in the age of ubiquitous and pervasive computing. That means that computers are all around us and in a lot of aspects of our life, but also in the area of the Internet of Things. So we have many devices able to connect to the Internet. And now the relationship between devices and users are many-to-many. So we have many devices for a single user, but also many devices that can be shared among many users. Let's think about a smart building or a smart cities, where we have a lot of free public facilities that can be accessed by everyone. Let's think in our cities to the free Wi-Fi. It is, there are a lot of free devices that can be accessed by everyone. So many devices for many people. And let's say that already we have, for example, in our pocket, we have already little computer with our smartphone. We have already a lot of smart objects, like, for example, we have the Nike Plus, just because the Nike Plus was one of the first smart objects. Now we have a lot of objects that are able to control and track our performance during sport. But of course, this was one of the first, and so we have a lot of data now to analyze, and was a really interesting case study. We know that already there are more devices than people connected to the Internet. This is very important because it means that things are able to share data and communicate maybe more than people. And we also see that when we we already said this, when we put computational ability inside an object, we also generate an information shadow. Can really say that every device can generate useful data, and this action creates an information shadow. The information shadow, it means that an object has this shadow of data that we cannot see directly with our eyes, but we can see through other digital artifacts, like I say, a musical CD that we can hear just with another player. The information shadow could be seen just with some other device, like the Google Glasses, augmented reality, mobile phone, or so on. So let's try to give a definition of Internet of Things. The Internet of Things is intended as a network of physical objects with embedded sensors and actuators that communicate with other objects, database, and in some cases directly with people. So an Internet of Things object is an object that is able to process information, so has some computational power. An object that is able to perceive data about the surrounding environment. An object that is able to have effect on the reality through actuators. Of course, we can have only sensor actuators, but it's important the relation with the reality. And especially the most important part is that the object can communicate with other objects. Communication is very important because it allows to harvest the data collected by the object. And so we can say that atoms are the new bits. During Fab Academy, we said that atoms are the new bits just because we are transforming big bits into atoms. So with a 3D printer, we can just turn a 3D model into an object. So bits become atoms. But when the atom, so a physical object, becomes smart, became able to collect and share information, then the atoms can become bits, and then from bits, atom again. So it's a circle, and it's a new way to intend information. And so, according to Mike Kunyaski, that you can see in the reference, information could be seen as a material. If you are a designer, you can consider information as wood, as iron, as another design material, because now computing is no more the final scope of an object. So computing is no more the last goal that moves me to design an object. I put computing inside an object just to make it more desirable. I put computation power inside an object to add functionalities, to make it more desirable and pleasurable for a user. So this is a WeThings balance board. This is a balance. Could seem a normal balance, so I see my weight, but the balance can also log the weight during days and can share data over the internet and over social networks. So I can share this data maybe with my doctor. I can share this data with my friends that are helping me to stay on diet. So if I don't lose weight, my friend can tell me that I'm not exercising enough. Or the opposite, they can say if I'm in good health or not. So here, computing is like a material. It's like an element that I add to give a plus to my product. Like in the toys industries, toys, I think, are the first example of objects that use electronics to be more desirable by children. When I have toys that make sounds or act like a little baby, of course, more desirable for a children. So what is the landscape of Internet of Things? Of course, it can be applied in at every scale, from individual to domotic, so smart building, but also to a community, city, regional, so we can think about smart cities, until a global scale. And the very big power of Internet of Things is the ability to collect data and have insight and a deeper understanding of this data to make smarter choices, and so to turn this understanding in new behaviors, but also to make automation and optimization of processes. So let's think about a smart city. We can optimize traffic. So we can see if there is too much traffic in some street, and then turn on and off traffic lights, or send messages to the drivers just to move them on other streets that are more free. So we can also limit the pollution and the energy demand. So what is the anatomy of a connected object? Now we built last week an echo board with a button and a LED. So we start learning about building electronics. So what is, from a physical point of view, the thing that we have to put inside a smart object if we want to do our Internet of Things enabled smart object? Of course, an Internet of Things smart object is an object that is able to react to an event. So, of course, it must have a sensor, something that is able to perceive some external event. In our echo board, we put a button. A button is one of the simple sensors that we can have. It perceives a pressure by the user. Then there is logging, so the ability to perceive data and to store somewhere, to make something with this data. And so I can collect the data and then upload to the internet. So I can make a network of objects. So I don't have anymore just one data, but I have a lot of data collected by a lot of very simple and small devices that can cost a few dollars, but I can make a very huge network. Then with this data, I can make analysis, and so aggregate data, analyze it, and using algorithm. And here I can do this on a bigger computer. So here, yes, I need a multi-core processor. So I can have a multi-scale architecture with a very simple object at the beginning, a very complex computational object at the end. And then I can take action. And this action could turn again to the beginning, so could go back to the object, and so make some effect on the reality with an actuator, or simply have a report to have a better understanding of some phenomena. So let's see some nice example of connected objects, and especially having a look on how about users interact with the object. Let's see the story of bread, the toaster. This is a project that was made by Giuseppe Rabadengo from Torino. And I look for the video. Sorry, I try to share. Ecco. This is a story of a connected toaster. So the question that is underneath this proof of concept is what will happen if a connected object will start showing a personality to the user. So if we start to interact with objects that has a personality, like an animated object. Let's think about when we start talking with our computer, or when we start talking with our car. Our brain is programmed to think that everything that shows a smart behavior is alive. So when our car suddenly stops working or gives some strange behavior, we start thinking that the car is alive. So again, we can start thinking that we can relate with objects, not only taking into account their functionalities, but taking into account their behavior. Now I have a problem loading the video, so I will just tell you what this toaster is able to do. And so this toaster is happy when you use it, and is not happy when you don't use it. And it shares this information over the network with other toaster. So when you start to ignorating it and to not using it, it starts to try to catch the user attention just by moving his physical pieces, trying to be used. And then if you don't use it for a long time, it sells itself over the internet. So why this concept is important to me? Just because it can show a new way to interact with objects, no more with buttons or command line, but with dialogue. Like you are interacting with an animal or with another human being. Then take another example, the Nest learning thermostat. This is a thermostat that can help you to set the temperature in your house, like a normal one. But this one has an ability, has the ability to learn about, to learn from your daily actions. So it's able to learn if the house is empty or not. It's able to learn about the temperature you want, and also see what weather is outside. So it's really a thing that once started, then you don't have to think about it. It's able to program by itself. Of course, this gives us a big question mark, because what is the good balance between automatic control and manual control from the user? When is correct to make a thing really automatic? Of course, the Nest thermostat is able to learn, but as always, a manual command, also a remote command. So the user is can always take the control of the situation. And in this case, it's a thing that helps us to be smarter, because we have to think about it just when we need. Not every day is not asking for our attention every day. Then we have now other example with a lot of things that are able to collect data about our actions. And we can see, for example, the Nike Plus or the Fitbit or the Jawbone app. And we can see this as a way to collect data and a way to use data to drive a virtuous cycle of learning and change. Because when we start to trace our action and our physical exercises, we can also have a look and to what we do and how we improve. And so we can have an additional motivation, but we can also have useful data, for example, to share with our doctor, or to understand why we are not losing weight, or if we are losing too much, or if something is going bad or good. We also have this nice sleep manager that is able to understand our brain waves and wake up us in the most appropriate time according to our sleep cycle. This is another example. It's called Glow Caps, and it's to help elderly people to take the prescription. In this case, we have it's a very nice example, and I invite you to have a look at the video, because here we have an ecosystem of objects. We have the cap, we have the package of the pill, but we have also other objects that we can put inside the house, because the designer imagined the life experience of an elderly people. So imagine that yes, the cap can glow and make a sound to remember me that I have to take my pill, but I can have it inside. I can have it somewhere, so I cannot see the light, and so I need other objects around my house that remember me that I have to take the pills. And so this is an ecosystem of objects that are able to interact each other to have an added value for the user. This is another interesting project. It's the high quality egg, and it as an example of crowd sensing. So with a really cheap smart device, each user is able to have its sensing device that share the data over the internet, and so it's a way for citizens to collect data about environment, and so to make an analysis of it, and so to maybe fight against pollution. Then now we have also plenty of object finders. So mostly using Bluetooth, object that devices that help us to find our object. This is interesting because when we put this tracking device on some object, then we are giving like an information shadow to an object. When I put the tracking device on my backpack, since that moment, my backpack has a digital identity. So this is no more just a backpack; it's a digital mine backpack. I can track how far it's from me. I can also share the information with my friend. If I lost something, I can share the digital ID of my object on the network, and so if someone finds the object with the digital ID, can tell that it's mine. So what is the challenge for designers? The challenge is to create new interaction paradigms and new media convention that exploit the new machine sensing capabilities offered by technology, and that can take care of human spontaneous ways to discover the real world. So what do we mean? It means that we have to design a technology that is able to disappear into the world, a technology that is just natural to use as it's natural to open a door, or it's natural to drink a glass of water. At the same time, for a technological point of view, we are still researching new kind of sensors to have a most profound understanding of the context. For example, if we want to know if someone is happy or not, what kind of sensor can we use? We have to use a mix of sensors, but we can only make a probabilistic attempt or just an heuristic about how is the emotional feeling of the user in that moment. And so let's talk about more deeply about natural interaction design. So of course we can see from the beginning of the computing, but also from the beginning of ergonomics that start with Industrial Revolution. That's the history of human-computer interface and interaction design is a path from complexity to simplicity. Let's think about command line interface and graphical user interface, and but also from machine that was designed for scientific purposes to devices that can be used in everyday life activities. So, of course, such process from complexity to simplicity influences current design practice that are still bound to metaphors that are derived from a technological reason. For example, the Windows icon menu pointing paradigm that we call WIM paradigm is still related to hardware and to technology, and not to user experience and to user daily activities. So, of course, we need new kind of interfaces. Let's try to imagine how it could be frustrating to interact with a mouse or a keyboard in a domotic environment. It could be really stressful. We want to that the lights goes on in our house when we enter, not when we click a button. or where we write a command on the command line of our smart environment. So we always talk about bandwidth for communication between computers, but we never talk about bandwidth for communication between man and computer. This is a representation of how we do look like for a computer. It's made by Daniel O'Sandoval and Tom Igo. So if a computer look at us, it will see us as a big finger that click on the mouse or on the keyboard, an eye, and sometimes a small couple of ears, just because these are the output devices that usually are used on computers. So we use keyboards for input-output, we use screen for output, and we use sound sometimes for output. But what is the reality? The reality is that our body has 5 senses and has can do complex movements. And when we talk with someone, we talk using our voice, but we also talk, especially if we are Italian, we talk using also gesture, non-verbal expressions. So we use a very rich full bandwidth when communicating with humans. So why we use a so small bandwidth when communicating with computers? It's for the reason that we need a solution. We need to increase this bandwidth, and we need new kind of interfaces. That could be multimodal interface, so interfaces that use multiple ways to interact with the user and with the computer. So we can use movements or sound or haptic feedback. But it's the way that we set up these interfaces that is important, because to have a useful and desirable multimodal interface, we have to change the interaction paradigm, going toward the so-called natural interaction. So, natural interaction, according to Alessandro Valli, that is an Italian researcher based in Pisa, could be defined in terms of experience. People naturally communicate through gesture, expression, and movements, and discover the world by looking around and manipulating physical stuff. So the key assumption of natural interaction is that they should be allowed to interact with technology as they are used to interact with the real world in everyday life, as evolution and education taught them to do. So the interfaces should disappear, because there should not be a difference between interacting with real world and interacting with technology. When we design a technology and we design especially an interface, we have to think as we were interacting with real physical world. But what is natural? This is a big question, and it's not related with technology. It's related to human beings. Because on our hand, natural activities are those that humans are made for, implicitly written in the structure of minds and bodies, like using the two hands, like the fact that we can walk at a certain speed, so related to ergonomics. On the other hand, other activities are here referred as natural, but they have a cultural origin. So the way we relate to other people is strictly related to cultural origin, but also our values, the thing that make us happy, or things that make us sad, have a cultural origin, of course. So when we design an interface, we have to take into account the physical characteristic of the user, but also its cultural origin. So from a design point of view, what are the characteristics of a natural user interface? So what we have to look at when designing a natural user interface? Of course, we cannot use the methods and the tools that we use for WIMP paradigm, but also the method that we use for user experience design and interaction design for the web. Because, of course, designing an interface for an object is really different from designing a web page. Even designing a mobile app is different from a web page, designing a web page, but designing an object is more than designing a smartphone app. Because with the difference between designing an app for a smartphone and a website is that we change the context. So the app can be used in mobility, outside the home, somewhere, while usually a web page or a desktop application can be used. It's used usually on a desktop computer. But when we design a natural user interface, we are changing the very first devices, the very point of contact between user and computer. So we are changing, we are transforming the keyboard maybe in a gestural interface. So we have to redraw the basics of interaction. So one of the main differences while approaching the design of a natural user interface as opposed to a graphical user interface is the concept of visibility and feedback. Indeed, the strength of graphical user interface has a little to do with the use of graphic. Graphic is for decoration, but the very important thing in the graphical user interface is that helps to remember action. A graphical user interface suggests us what actions are possible with some system, and also suggests us how to invoke them. Remember the example of the hair dryer and the computer? Okay, an icon, a graphical connotation is like the handle of the hair dryer. So it's the affordance that help us to understand what we can do and how to use that object. So the important design rule of a graphical user interface is visibility. But when designing a natural user interface, we're thinking about an object, maybe the visibility is not so explicit. So if I don't know, we want to make a domotic appliance, maybe it's not visible. We can see the effect. So when we enter into a room, the light goes on, or when the temperature goes below a certain level, the heater goes on. We can see the effect, but we don't have a visibility on the system status. We don't have the visibility of all the functionalities available. So this kind of system could be learned through exploration. Systems that avoid this well-known method suffers, of course. So it's difficult to explore a natural user interface system because a lack of visibility, but there is also the lack of feedback. So imagine that I have a domotic system. I program it to turn on the light when I enter inside the room. I enter inside the room and the light doesn't go on. Something is going wrong, but I don't have a real-time feedback on it. So I don't know if I did something wrong or if the system is not working or is not programmed properly. Why? Of course, on a desktop application or a mobile app, of course, I can find some error messages or something that will help me to will help myself to understand what is going on and how to fix it. Let's think here also about the experience of playing with Nintendo Wii or with the Kinect, with the Xbox. When sometimes we do gesture, but we don't know if we are doing it properly. And so we just see to the effect that we has on the game, but we don't have a feedback that tells us that we are doing good or bad gestures. Another very important thing that we have to take into account when designing a natural interface for a smart device, for an Internet of Things object, is the context. We can divide the context in two: a physical context and an informational context. The physical context is, of course, are the variables related to our environment. So the system must understand the physical context we are into, because it can take proper action. Let's think to the in-car navigator. The in-car navigator is able to understand the physical context through the GPS coordinates, and is able to take us home, just suggesting the most appropriate route. And a system could also be able to understand temperature, pressure, lights, and a lot of other physical variables that could be used to automate something, or just to give information to the user to adapt the interface, and so on. And then we have the informational context. The action takes place in an infoscape. It's necessary to represent the relational structure. What does it mean? It means that there is a context made by meaning, by culture. It's made by something that we need to understand, that we are thinking about. So the interface should be able also to relate to the informational context, to our culture, to the things that are that are around us, to deliver context in an appropriate way. One of the most important things in designing every kind of interface and every kind of system is how we treat cognitive load. Cognitive load is intended as the ability of our brain to process information, to take decision, and so it's limited, and it's also variable during time. We know that when we are tired or when we are upset, our ability to create, to invent, but also to take decision is not as good as when we are relaxed or happy. So an interface should take into account how to manage the cognitive load of the users, and also to relate to different states of the user. So we are surrounded by things that are that ask for our attention. Of course, we talk about pervasive computing, ubiquitous computing, Internet of Things. It means that in every corner of my house there is something that is that has a microcontroller that requires my attention to work. So I have to program it, to configure it, to check if it's working properly. So it can drive me crazy, of course, because our brain should accomplish two different tasks at the same time. And it's not good, because the focus of our attention is just one. We can concentrate on just one thing at once. We are able to make multiple things because, not because we are multitasking, but just because we make just a list of things to do, and we do this in sequence. But we are so fast that give us the impression that we are making things together. But when we start to drive and text, we go to crash with our car. And this is the proof that we cannot do two things at once. So interfaces and objects should not ask for our attention if it's not necessary. And also, especially, natural user interface can reduce the cognitive load. Why? When there is a stimulus, the brain searches for the corresponding schemes of action. This is, I don't know if there is some psychologist that is listening, but this is a cognitive, of course, approach. So in a cognitive approach, our brain has different scheme of action, and the brain activates the scheme that is less expensive in terms of effort. So if a system induces simple schemes, the interaction is more straightforward and not fatiguing. Why? If I have to understand a complex interface, I have to understand a complex message, I have to activate more resources in my brain. It's for this reason that we do infographic. It's for the reason that we communicate through images more than with text. Because reading text involves a cognitive process. So I have to read the words, recognize the letter, then make sense, and then have a proper action. The image doesn't have the mediation of the language. It's more intuitive, so it's more straightforward. So with natural user interface, I don't have to take a mouse in the hand and understanding that it make a mediation because an horizontal plane to a vertical plane. But I can directly touch a touchscreen interface. So I just recognize that I want that icon, that is open the door, the command, and then I just go and push that command. So the higher is the level of abstraction of the interface, the higher is the cognitive effort required for the mere interaction. Representing high-level information, especially context data, through elementary sensor stimuli reduces mental effort. So we say that our attention has only one focus, so we can concentrate on only one thing at once. But when we drive, as I make many times this example, when we drive, we also use the rear mirror. So in the rear mirror, our attention is on the road in front of us. But we can perceive if there is something strange going on in our rear mirror. So if we see something strange, our attention, our focus go immediately on the mirror. So because we have the periphery of attention, an area where there isn't the focus of attention, but there is a very low level of attention. But it's the periphery is full of the things we don't pay attention to, but we are aware. So are the things we don't focus on, but we are aware of. So information should be simple to be processed fast. What is in the periphery at one moment may be in the next moment come back at the center of our attention. Think about your mobile phone. You carry it in your bag every day, and you forget that you have in your bag. But when it starts to ring, when there's a call going on, it comes to the center of your attention. So this should be a rule that you use in designing your natural interfaces, your Internet of Things object. You have to design something that should be in the periphery of your attention and demand for your attention just when it really needs, and in a natural way, so it requires a very little cognitive effort. Then we are social animals. We are always in social context. So when designing a natural user interface, we also have to think about how it can be perceived in a social environment. So a natural user interface should be socially acceptable. What does it mean? Imagine a gestural interface, and imagine you drawing with your hands like a crazy in the middle of a street. Or, for example, when you talk with your headset in the middle of the street, people for sure will be looking at you like a crazy. So you will not feel comfortable. And for this reason, when you design an interface, you don't have to think only about the functionality, but you have only one user. But you have to think about where the user will use this kind of interface. Then, of course, there is it's important to take into account aesthetic and emotion. Emotion and beauty could influence interaction. Donald Norman, in an interesting book, says that when your car is clean, it seems to work better. What does it mean? Of course, cleaning the car doesn't have effect on the engine. But of course, you are in a better mood when your car is clean. And so you are more tolerant to mistake. You are more creative. You're more prone to be happy. And so natural user interface should also put you in this mood, should also be pleasurable. For this reason, we give so much importance to the experience, to build a correct experience, to build an interface that gives you a good user experience. Of course, natural interaction involves movement, as it involves body. So we can use movement as an input, so we can make a gestural system, but we can also use movement as an output. So, for example, a thing can move just to tell us that something is going on, or I want to see if I can show some video of it. But,
in times of need of change,
like animals communicate with us with movements, also objects can communicate with us in the same way. For example, I told you at the beginning about bread the toaster. It communicates through movements. I see if now it's possible to share the video.
Like all of the other toasters, Brad is programmed to love being used.
So
he is also sensitive to the use of other toasters, so sometimes he feels a bit of pressure.
So let's see. The toaster see the other toaster I used it, and it starts to
Brad
move.
cannot be owned.
It starts to move just to communicate that he feels a little bit of pressure because he's not feeling satisfied because it's not being used. Let's go to okay. No, it's the buffering isn't complete, so
he will remark upon how satisfied he is.
Here, the toaster is communicating through movements, and it's nice to see it because looking at this video, we realize how much our brain gives a soul, gives to an object just because it's moving. Look at it. The toaster starts moving and then react to the user touching it. So in this moment, in this very moment, we are looking at the toaster like an animal, like a cat or like a dog, because it's with movement and not with text or with voice. It's communicating something. So this is really important because we often think about movement as an input an input method, but it's of course an output method. But we have to use it in an appropriate way. And for doing this, we have not to study technology, but we have to study human. We have to study cognitive schemas. We have to study animals, the way they communicate. And so we can emulate, for example, the behavior of a dog, of an insect, or something. Using movements is not so easy because there are implications, especially related to ergonomics of the interface. Because we have to consider the whole body and the duration of the interaction. Of course, it could be very fatiguing to use a touchscreen to write a master thesis, because it could be a very long and a very big effort. And also, not all the category of users can do the movement, because I have impaired people, so I have to think to different category of people. Maybe a young user can act in a different ways if compared with an elderly user. And also, it can be also dangerous. Someone of you maybe will remember the website We Have a Problem, that is a collection of images and posts related to the images made while playing with the Nintendo Wii. So that user making some big movements, they start to hitting the children or people that were standing near them, or breaking the TV screen, or breaking window, or breaking furniture inside the house, just because they were moving in a place that is not adequate to the game. So gestural interfaces are made with movement, but one problem with gestural interface that gestures are ephemeral, so they don't leave behind any record of their path. When we type something, there is the record of what we typed. So if we write down a bad command, we can also remember, see what was our mistake, and then correct it. But when we do a gesture, how we can compare with the previous one and tell that one is good and one is bad, one work and one doesn't work? The requisite of feedback is lacking. When we play with the Nintendo Wii or with the Xbox using the Kinect sensor, and we do some gesture just to throw a ball or something, we don't have an immediate feedback. I already said it. We don't have an immediate feedback if we are doing a good gesture or a bad gesture, but we just can see the effect. But we are concentrated on what is in front of us and not on our gestures. So it's difficult to tell where is our mistake. And so it's important to give a constructive feedback. So we don't have a direct feedback, but we can give the user constructive feedback, a progressive feedback that helps you learn something. As you learn going on a bike, as you learn skiing, skating, and so on, you learn it with a constructive feedback. So looking at the effect of what you are doing, you can understand how is the right way to do something or not. So of course, using gesture is not only using touchscreen, but is using I say the interactive screen, interactive projector surface, or using, for example, the node that is a ring that you put on your fingers, and you start using your finger to make and hand to make gesture. And then when we use a thing like a Xbox with Kinect, how can we have a feedback? For example, the Disney research made the iReal project. The iReal project gives a force feedback using air under pressure. So if we are playing with the Kinect, I try to share the video. If we are playing, we know that we have something hitting our hands, because there is a small nozzle that sends air on our hand. Let's see if we can share the video.
Physical world without any instrumentation of the user's body. Aerial enhances a user's perception of virtual 3D elements by creating physical forces the user.
So in this case, the user has the sensation that the ball are hitting his hand, just because there is a air going into his hand. It's a 3D printed, of course. So this could be a way to have a feedback about our gesture, and so to have a more complete interaction. And there is also this very interesting project from MIT that is an haptic display. With some actuators, it's able to reproduce shapes, and to, of course, with digital information transmitted over the internet. And So it's possible to touch and to have a direct feeling of digital object. It could be a way to visualize your 3D model and to modify your 3D model before sending it to the 3D printer. Moreover, what we have seen during the last assignment is that we can embody the interaction into the world. So we can make an electronic device and maybe put it inside an object. So the computing is embedded into something, and this is embodied because computation manifests itself into the world. Paul Dorish wrote that embodiment refers to the way in which interactive resources manifest in an interface. It does not refer simply to physical reality, but denotes a participative status. It points to the ways in which we interact as involved participants, rather than detached observers. So embodiment means that interactivity is and computing is really inside an object, and computation is in the texture of the reality of the world. So it's not more a separate thing, but it's melted with the real object. And so, for example, we can see a lot of smart devices that have computation inside and that are so natural, so intuitive and immediate to don't feel us that we are using a computer. Of course, we can have to take into account also space as a spatial organization and architecture, because it's the place where the interaction takes place. So also take into account how humans feel space, and be aware that there is an interaction zone, a personal zone, and a social area that we have to consider when designing different systems. A useful technique that you can use to design interfaces is body storming. I like it very much because it's like brainstorming, but done with body. It may look different depending on the preparation and location, but at the end, body storming is fundamental about one thing: getting people to figure out things by trying things out. So one of the best way to design interactive object is to pretend that you already have it in your hand, and so pretend they are magic. So usually you will care about technology and wonder that you don't know how, if sometimes if possible or not. But in this phase, you just have to think that you have a magical wand. So you don't need to know if from a technological point of view it's possible or not. You just have to pretend the object is already there and you are using it. And then you start thinking if the functionalities that you put inside are enough or are too much, and if the interaction paradigm is good or not. Then usability studies maybe are a little bit complex, but you can take some test user to see if they, in an intuitive way, can interact with your prototype. And to do this, you have to find a good metaphor. Metaphor is something that help you to understand something that you don't know using something that you already know. So Kuniaski said that design requires using tools skillfully, and metaphors are the tools of thought. So when you use a metaphor, think about the desktop metaphor. It helps you also to understand things that you don't know, because if you know that the bin is something where you put the thing that you don't need anymore, the folder, the file, and so on, it's a metaphor that now is so spread that it's very intuitive. For us, it's impossible to think, to don't understand the desktop metaphor. So we have to find metaphors for smart object. Of course, it's difficult because it's not so easy to find a metaphor for an object and for an interaction paradigm that doesn't already exist. So as we are running late, I directly go to an interesting part. Of course, doing prototyping or just acting like we have an object is important. For this reason, also the digital fabrication is important, because we can do prototype and we can test with the user. We can make usability tests and A/B testing of our things. But in conclusion, one of the most inspiring way to design and to think about natural user interface is using enchantment. I borrowed this this last part from David Rose. There is here a link to his presentation. So when I have to design an interactive object, I try to think about something that is enchanted. David Clark here is, I think that exporting PDF something is not readable at all, but Arthur Clarke says that any sufficiently advanced technology is indistinguishable from magic. What does it mean? It means that for us it's not important how a thing works, or if there is a microcontroller inside, the sensor, an actuator. It is important if we are the designers of the object, but it's not important if we are the user of the object. So for us, digital objects could be magical. And so we can imagine to design magic stuff. We have in our imagination, especially in our childhood, plenty of story that we can take as an example. In a lot of fairy tales, we have objects that have superpower, or that can make something extraordinary. And usually magic is represented inside object. Like in Narnia, Lucy, magical healing potion, or in Dorothy, magic teleportation shoes. So we can imagine to design, or in the last of Wonder Woman. So we can imagine to use the electronics we learned in Fab Academy to make enchanted object, to make magical object, to take your most favorite fairy tale and make an object that can give you superpower. So, for example, there is the sword that Frodo uses to detect if orcs are approaching. We can just see that there is also an umbrella that is able to light up if there is rain. So when we are going out from our house, we can sell we can see if we have to take or not the umbrella. So this could be an example of an enchanted object. So we don't need any button, we don't need any screen. It's just a magical umbrella that lights up if we have to take it. No attention is required. It requires our attention just when it has to be used, and it makes us smarter because it enters in our attention just when it's strictly necessary. So, for the conclusion of this lecture, of course, we are going toward a reality and a scenario where we will be surrounded by objects. But technology should only be a tool. We always have to take into account the final goal of the user, and know that the user, first of all, wants to be happy, wants to use something that is satisfying, wants to reach his goal, but not only reach his goal, wants to reach his goal in a very pleasurable way. So I leave you with this question that is the same of David Rose. Which object should we enchant during Fab Academy? So I thank you for your attention, and if you have any question, there is my email on the presentation. You can write me or Skype me or what you want. Thank you. Bye-bye.